Hey everyone, welcome to today's Explainer. So, you know that feeling when you're on your morning commute, you look up at a massive construction site, and bam, there's a giant crane towering hundreds of feet in the air. Like literally a week ago, that spot was just an empty lot. It really makes you wonder, how on earth do the massive machines that build our skylines actually get up there in the first place? It's kind of like this giant, seemingly impossible logistical puzzle.
So, seriously, how exactly do you build a skyscrapers builder? It's a question that hits almost every single one of us navigating a growing city. These silent giants just seemingly appear overnight, right? Ready to start lifting tons of steel and concrete, literally shaping our world from the clouds. And no, they don't just roll up fully formed on the back of a truck, and there's definitely no helicopter dropping them into place. Getting them up there requires this incredibly complex, highly orchestrated process that, honestly, is just as impressive as the skyscrapers they actually built.
But to understand how they get way up there, we actually have to look all the way down at the ground first. And I think this number right here brilliantly illustrates the sheer scale we're dealing with. 400,000. Before a tower crane can lift even a single steel beam, it needs extreme grounding. A standard tower crane's concrete base pad can weigh an astounding 400,000 pounds. That is a massive footprint, but it's absolutely crucial to ensure that when this machine is hundreds of feet in the air hoisting massive loads, it stays perfectly rock-solid stable. Okay, part 1, Giants of the Skyline, and setting the stage for construction. So, right off the bat, there's a pretty stark contrast between the two main types of lifting machines you're going to see on a site. On one hand, you've got mobile cranes. Now, these guys have limited height and a pretty large footprint, but their setup is incredibly fast. On the other hand, we have our main subject for today, tower cranes. These give you superior height and reach and a remarkably small footprint, but the trade-off is a super complex assembly. In fact, to even build a tower crane, we have to bring in a mobile crane to act as kind of like our supporting character. The mobile crane has to do the heavy lifting early on, so the tower crane can eventually take over the show. And before we start stacking all those massive steel pieces together, we really need to understand the slewing unit. This is the rotating mechanism mounted right on top of the crane's vertical mast. It houses the motor and the gears that let the entire top of the crane rotate horizontally, a full 360 degrees. It's literally the pivot point for all the work the crane is going to do, giving it this massive working radius over the entire construction site. Moving on to part 2, pouring a solid foundation, groundwork and stability. Like we talked about, extreme height absolutely demands extreme grounding. So let's walk through the site prep methodically. First up, engineers have to conduct rigorous soil testing and site clearance, just to make sure the earth itself can even support this massive machine. Then they pour that huge 30 by 30 foot concrete pad we mentioned a minute ago. But wait, it's not just some rough pour. They actually use laser level alignment to make sure it is perfectly flat. Because think about it, any slight tilt way down at the bottom translates to a seriously dangerous lean hundreds of feet up in the air. Finally, they embed these heavy-duty anchor bolts directly into the curing concrete. The crane's base is eventually going to be bolted straight into this massive pad to make sure there's absolutely zero chance of it tipping over. Section 3. Building the initial mast with the mobile crane assist. All right, this is the fun part, where the giant steel components finally arrive on site, usually on a whole fleet of flatbed trucks. Now, since the tower crane obviously can't pull itself up by its own bootstraps from the dirt, our trusty mobile crane swings into action. It methodically hoists the heavy base and those initial vertical mast sections, which, by the way, are basically just really large steel lattice frameworks, into their vertical position. From there, the assembly crew basically snaps them together, bolting them super securely like giant steel puzzle pieces, stacking them right up to a predetermined initial height. Another absolutely crucial piece of the puzzle at this stage is the jib. Now, the jib is that super long horizontal boom or arm that extends out from the slewing unit. It's the part that's actually doing all the lifting and maneuvering of loads across the site. Using that mobile crane again, the crew hoists the slewing unit onto the top of the mast, and then follows it up with the jib, the operator's cab, and finally the counter jib on the opposite side. Oh, and that counter jib gets loaded up with some incredibly heavy concrete counterweights, just to keep the whole shebang perfectly balanced. So you might be wondering, why go through all this trouble? Well, it's because of numbers exactly like this. 18 metric tons. That is the unbelievable maximum lifting capacity a tower crane can hit when a load is positioned close to the mast. It is just this total marvel of mechanical physics, right? Power-driven energy transfer and structural force balance all coming together perfectly. When you've got a machine that can hoist 18 metric tons of steel beams straight into the sky with pinpoint precision, yeah, this whole complex assembly process is definitely more than worth the effort. All right, section 4, how the crane climbs, the hydraulic magic trick.
Okay, let's dive into this because this is where it gets wild. How does the crane get taller than the mobile crane can even reach? Well, it literally climbs. Step 1. A climbing frame, sometimes called a jacking cage, attaches around the outside of the top of the mast. Step 2. These massive hydraulic jacks push against the mast, and they physically lift the entire upper section of the crane, the slewing unit, the cab, the jib, all of it, straight up into the air. Step 3, the crane actually uses its own hook to hoist a brand new mast section up from the ground and slots it right into that empty space underneath it. And finally, step 4, workers securely bolt that new section into place. Then, the whole process just repeats. It's this beautiful, repetitive, mechanical, hydraulic process that literally allows the crane to magically grow right alongside the building it's constructing.
As our sources for this explainer put it, this ingenious technique allows tower cranes to gradually extend their height as construction progresses upward. It perfectly summarizes the absolute engineering brilliance of this telescopic climbing process. It's just such an elegant solution to a really, really heavy, complex problem. Part 5. Safety in the skies. Commissioning the giant.
Now, before this crane is ever allowed to lift even a single piece of actual building material, it has to undergo some incredibly strict commissioning. Technicians are up there inspecting every single bolt and wire rope. They're testing the safety limiters, like height limiters and moment limiters that actively prevent tipping, along with all the emergency stops. But what's really interesting here is they do a load test with 1.25 times the rated load. They purposely push the crane past its official limit just to absolutely guarantee it can safely handle the unpredictable forces of a busy, windy job site. And speaking of wind, they set up constant environmental monitoring because operations have to shut down entirely if wind speeds get too gnarly.
So, when you actually step back and consider all of this, the massive 400,000-pound foundation, the insane coordination of all those flatbed trucks, the mobile crane assist, the hydraulic climbing frame, the extreme safety load testing, it is completely staggering to realize that this entire assembly and erection process typically takes just 2 to 3 days to complete. 2 to 3 days. It's a massive testament to the astonishing efficiency of these assembly teams. In literally less than half a week, they can transform a flat patch of dirt into a soaring, fully functional steel giant that is ready to build the future. Which really leaves us with this final, provocative thought. How will these silent giants shape the cities of tomorrow? The very next time you're stuck in traffic on your commute and you see a tower crane resting high above the skyline, you're going to know exactly the monumental feat of engineering and the sheer human coordination it took just to get it up there. Honestly, it completely changes how you look at the city around you. Anyway, thanks so much for joining us for this explainer, and keep your eyes on the skyline.